Well, hi, good morning. Thanks for joining me in my shop. It's January 6th, 2019. Holy smokes, and I remember thinking about 1984 was going to be something. So here we are with this basically a microphone preamplifier here, which I did use for a while. I actually made videos with this, thinking it was just an ordinary amplifier, preamp, built for microphones, until I discovered, this is maybe 3, 4, 5 years ago, that this thing produced a huge hiss. And I had this all over my videos for 4 or 5 months while I used this thing. So I retired it, and it's just been sitting around until most recently I was poking around on the internet with this APHEX Tubessence, trademark, Tubessence, 2-channel thermionic microphone preamplifier. Thermionic. Wow. So I started reading a little bit about it on the internet, and guitar players like to play around with this guy. So I play a little bit of guitar, and, just to entertain myself, nothing more. But I got this out and I started toying around with it, and I got, hey, this is getting to be a little more interesting than I thought. Now, a couple things I've done to it previously, since my microphones don't have this kind of input, I've rewired this internally and stole off the back of it here. You have an output and an output, and this is a remote mute normally, but I've rewired these, so these are the inputs now. So you can plug your microphone in here and the output comes in there. It's a 2-channel guy. So let's just take a look at what it says back here. 2-channel microphone preamplifier model 107, APHEX Systems Limited, Sun Valley, California, made in the USA. APHEX and Tubessence are trademarks of APHEX Systems Limited. 24 volts AC, which is a little bit unusual, right? 24 volts AC. I have a power supply that does that. So operating level +4, -10. So I think this is to control, well, obviously it's to control the output here a little bit. Funny to have it on the back here. Tip, close to mute. So this is just an explanation of how to use this remote mute, which is no longer a remote mute, it's now the output. I'm sorry, the input. Input, output. It's got an awful lot of buttons and lights on the front here. One thing it doesn't seem to have is an on-off switch, just a straightforward on-off switch. So I'm going to plug the power in the back here. Watch all the fun lights go here. So you see the red lights are on, overload is on, the OK light is off. Now there is one, as I understand it, there is one vacuum tube inside this guy. This has got what's called a starved plate design. Starved plate means just what it sounds like. The this is a low voltage device, even though you're feeding, well, you know what, you're feeding into it an AC voltage, so you could transform it into anything inside here. But my understanding is the concept is you run the vacuum tube with a very, very low plate voltage. Why in the heck would you ever do that? So this is the part I kind of missed about this thing. This is an attempt to introduce distortion, believe it or not. The idea is you're introducing maybe 15% distortion created by a vacuum tube. The key thing being that harmonic distortion created by a vacuum tube occurs on even harmonics, which are pleasant to the ear. Whereas transistorized equipment, this is not me talking, this is what I've read, and I don't know what the truth is, frankly, but the idea is transistorized equipment produces harmonics, the third harmonic rather than or odd harmonics, I guess is the way you can put it, odd harmonics, which are grating to our ears. We don't like to hear them. That's the theory. So taking that concept, if you like, and applying it here, this is the sales point here, by putting a tube in and operating it such that it provides a low level of distortion, it in fact provides pleasant kind of distortion that people often sense when they listen to tube equipment. Again, that's a theory. I'm not buying into any of this, by the way. And so that's why you produce this rather nicely built transistorized microphone preamp, shove a tube in it at some point. The tube is back here. I can feel the usually I can feel a little bit of heat right in here. This is where the tube is sitting. It's a 12AX7, which is a well-known amplifier tube, very popular with audiophiles and guitar people and all that kind of stuff. So that's why it's got a 12AX7 in it, so they can say that to you. Funny it doesn't have it written right on the front here, blasting it out somewhere. So that's the whole idea. Introduce a little bit of harmonic distortion in a pleasant way. Call your device Tubessence. You see, it has the essence of a tube, but don't bother putting the high voltage power supply in here, which has consequences. In doing that, the design issues get raised. I think there's problems with doing that. So keep a low voltage, and then of course what's happening is you're operating the tube way out of its characteristic curve where it's been designed to be operated, the low plate voltage, and this produces the distortion that you're after. That's the whole idea, believe it or not. And what I discovered with this guy, which we're going to experiment quite thoroughly with it, is when I turn the levels right up, just even with nothing plugged into it, just the last say 10%, this huge hiss comes out of this thing. And unfortunately, when I was making videos with it some time ago, that's how I had to have these things turned up full. My arrangement at the time required it. So let's take a quick look at these lights here, and then we'll start goofing around with it. So 20 dB pad, on and off. I notice the button over here is sticking, and it's stuck on. So this side is padded right now. This button is. I don't know what happened to it. It's sticky and it's stuck on. So I might have to, once I get the top off, we can poke around with this too. So it has a OK light, which is not on right now. It has an overload light. Okay, think about it now. This is supposed to produce distortion, but it has an overload light. It has a polarity inverter. This is because I believe some microphones receive voltage to operate. There's the 48 volts that can be transmitted. If you turn this on, you can send 48 volts, I guess, out of here. I don't really know, to be honest with you. I'm a little clued out about that kind of stuff. And I missed this, 80 hertz low cut. If you want to knock off some real low bass stuff, you can push this button if you like. And these same things are just replicated over here. Never noticed this one muted. Well, of course, if you trigger the mute, which you can't anymore externally, but if you could, then I guess this light would come on. So lots of lights just laid out like this. So what I want to do is I'm gonna plug this guy in to my microphone mixer. That's what all these cords are here for. Okay, output. And blue one and a red one. Output. Okay, so these are going to go into the back of my, what you could call an auxiliary mixer right here. Okay. So we're going to put it in. Let's try these two here. Okay, so that equates to these two controls, and also on the main board over here. This is the control for this whole box. So I'll be able to feed the output from the preamp straight into here, which means I'll have to listen to it with some headphones, because obviously I don't have a speaker in my shop playing what I'm recording, or there'd be feedback sitting in here. So I normally do not listen to my recording. I just try to keep an eye on the record level. But I put these on, and I will hear my voice in here. So now we want to plug microphones in here. I have a couple choices. I think the microphone I'm going to plug in here is a really nice auxiliary microphone I have on it's my right side shop microphone. Oh, it's been on all this time, which I seldom actually use. Let me bring it up here. I have 3 microphones running in here right now. I'm going to switch to just this one. Oh. Well, okay, that hurt. That hurt a lot. What I'll do is I can put a little bit of this in. Put a little more in. Here. Wait a second, I'm all turned around. Hold on. I sort of clued out there for a minute. There we go. Now it's working good. Okay, so this is, now let me just turn off the other ones. Okay, so now this is the other microphone I used to use a lot. Has a very different tone, doesn't it? Really different tone from the other microphones. So what I'm going to do now is I'm going to plug this microphone into this, and we'll hear what it sounds like with some luck here. Can I put that there safely? Can I do that? Looks that way. Okay. I gotta get the plug out of here now and get it over there. So, okay, so I'm switching to my regular microphones. I have to find the. Hopefully. Oh, this microphone wire might not make it all the way there. Just bear with me a sec here while I move around a few wires. Get there. Looks like it. So this now is the end of this microphone. The cord's actually wrapping all around my shop. So we're going to flip this around now. I'll plug this in. We'll start with let's do channel 1. Hope this works. Channel 1. Turn this one down. Okay, microphone's on. Okay, I'm going to turn off the regular mics. Okay, so I was doing some experiments there, and I just noticed the audio level into the video recording was just right off the charts. So that happens because I'm listening with headphones, and the normal level of audio, the way everything is arranged in my shop, the headphones don't produce enough sound to hear it. So my tendency here is to keep cranking up my microphone levels when I have headphones on until I hear it, and by then it's super overloaded on the video. So that's what's going on. I'm probably going to not post the last 5 minutes or so because of the problem that happened. So you're listening to me now through this microphone, through this. And I can turn it down, turn it back up, back up, back up. What my personal problem here is I can't hear this now. The headphone level is so low, I can't hear what it sounds like. And we're listening to one channel. If I turn the other channel up, it's like nothing happened. So I'm going to switch the mic onto the other channel. We'll test it out. Let me turn this one down. Okay, there. How do you like that? Okay, so I found out there's something going on. Yeah, I should do more of this. I find out a lot of stuff I think is working isn't actually working. Okay, so now you're hearing me out of this channel. And you can see the green light is flashing there. It's a little hard to see. Yeah, you can see it. So we'll turn this up until we get a little... Oh, it is up. It's up full. Up full. Up full. Hello, hello. So this sounds a lot different than the other one. Hello, hello, hello. Full volume. Wow, okay, so if that's full volume, wow, it's a huge difference in this thing. So, you know what, it's this stupid stuck button here, because if I push this, now we're probably the same now as this one over here. That's probably what's happened here. Yeah, this button is stuck. Easy for me to unstick it here. I'll do that in a second. Do it right now. Do it right now. Yeah, so this is the microphone I use to record all of my videos up until I acquired a stereo microphone. The stereo microphone is right here. This is a stereo microphone, so that's now my standard microphone. Okay, let's just see if we can pop this button out here. That would be easy. It's pretty sealed up. More going on here. Okay, I'll have to fool around with that later. It's not, I thought you just touch it, it would snap back, but it's going to take a little more effort. So, staying in the strong channel now, with the volume full, see how I had to have it right up at the top here to get enough oomph out of this thing to drive the it. I do if I get close to the microphone, we can get a really good result here. That sounds pretty good. Is this thing doing anything? This tube sounds perfectly fine to me. Let's plug in the guitar, because that's where the truth is going to come. I have my guitar in here. Hang on. Okay, I'll put on my other microphones before we forget. Okay, where's the... So that's my guitar. Okay, so what I'm going to do is I'm going to pluck one string and we'll listen to it. We'll just pick one in the middle here. So this is tricky for me to do as I'm watching the levels here. I'm not watching them so much on the video. So again, they're going off the charts on the video. So distortion you hear could be from many other things aside from what's happening right here. If you're hearing distortion, that's so that was not very impressive. Let me turn the levels down here a bit. So you can hear now. You can hear distortion in that. I'm pretty sure. Plug it again. That's clearly distorted. I can see why guitar players like this. Listen to that. That sounds great, eh? Turn it back a bit. So we get rid of the green light. What do we hear? It's pretty quiet. Turn this down a little further. Turn this up. Well, basically, I'm feeding a microphone mixer into a microphone mixer into a microphone mixer. That's what's happening. It's a lot. So I would say that's not very distorted at all. Green light not on. So it looks to me like it's true. When you get the green light to come on, you've got a level of distortion here. Let me pluck it and I'll turn this up and we'll see the green light in the whole deal. Oh man, I want to play that guitar. That was a little too loud though. Let's try that again. Just still trying to get the level on the video correct, so you're hearing what's really coming out of here. I think that's just about where I have it now. I saw that flashing a bit. Too much, it's saying it's too much. The red light's coming on. So basically, green gets you into the zone where there's distortion, and red means you've gone too far. And you probably, look, I mean, there's all kinds of places where distortion could occur in here if the signal gets too loud. I guess maybe what they're trying to say is when the red light comes on, now you've got other solid state components that are getting into the act, and you don't want that. You just want this, it's just flickering. That's how long my guitar is still making a sound. Well, it's, what could we do? We could put this through an audio analyzer and we can look at the kind of harmonics that are being produced by it. Let's give that a try. Okay, so we're looking at a piece of analysis software. You can see my voice bobbing up and down there. The lower display is a frequency display, so it shows what kind of harmonics and things like that are occurring in the signal we're listening to, if you can spot the primary frequency, which is usually the lowest frequency. So I'm going to pluck the guitar here. I'm going to turn the gain down a little bit so we don't get so much distortion. See what we get here. I'm plucking. Now, it has a lot to do with, where you pluck the string. If you pluck the string towards the ends, you get harmonics in the string vibration itself, which gives it a pleasant sound. If you pluck the string dead center, you get the least number of harmonics. But even there, you cannot pluck a guitar string without introducing harmonics. So, what are we watching exactly? I don't know, but here. It says, what do you got to do? I got to put on my guitar here. Okay, this is really awkward in my shop. Guitar is a big thing to have kicking around here, so let's see what we get. Okay, so on this note, I see a very distinct peak at about, I'd say that's 130 hertz. See another one at what would be, well, if we say it's 150 for the primary, then we see at 300. And then, so we see one at 300, and then what do we see? We see something at 450, roughly. First 2 or 3 tones, maybe 1, 2, and 5 are fairly strong. Up to 5 maybe. Okay, so I'm going to introduce distortion here. Volumes and levels are going to go crazy when I do this here, so hang on. So down, I got another volume control now right on the guitar. Okay, so the input level is up high now. Okay, let me just... You got too many volume controls to fool with. Now you can hear the distortion. You can see it. Like you can hear it. You can see it. So what do we got? So now we got one a lower string here. So back to 150 primary. 300 looks kind of the same, doesn't it, really? So I'm going to turn the volume. This is tricky now. As I turn the volume down, and the signal is going to go away. But I want to try to see what it looks like with and without the level turned up so high that there's distortions. Come on, guitar. Play that note for a long time. Okay, level halfway. You can hear these different sounds in the string itself. Those sounds are the harmonics. It depends on how I pluck it. So I'll pluck it right in the middle here. Ooh. Okay, try it again. There we are. Turn it up a little bit. Okay, there I saw something. Now, what I'm doing is I'm plucking the string with the volume medium. I'm then advancing the volume. Watch what I guess we can call the first harmonic at around 300. So we'll start with the volume down a little bit. Here we go. You know, this is just a terrible way to try to demonstrate this stuff. You know, hey, I don't practice these videos ahead, you know. I get ideas and then I come in and do them. So one thing I can see is up around 2K, 3K area. As I turn up the volume level, introduce more harmonics, I see stuff show up there and I can hear it. So let's try that. So watch on the screen around 2 and 3 as I up and down the volume here after hitting the string. Once again, it's a crappy demonstration of, I thought what I was seeing was higher harmonics showing up. You know, but because we're fooling around with the volume, everything's going up and down. It's really hard to sort out. Okay, let's just give it a go at the guitar amp. Oh, look at that upper display. That's more interesting. Squarish wave going by there. Then it's smoothing out into a sinus, so you can hear it. You can hear the higher harmonics leave. Let's try that again. So forget the bottom display. Look at the top display. Smooth, rounded signals have few harmonics. Sharp pointed, sharp edged, cornered signals have high harmonic content. So I guess if you think about it, the string is a tuned circuit of a sort. It's tuned, and so when you first strike it, you've got all these different vibrations. Many of them die out very quickly because they don't fit into the vibration of the string well, and then you're left with the main vibration and all the harmonics, and that's what goes on for a long time. But you can see what really happens is the higher harmonics fade out. They can't sustain on the string. The primary harmonic, of course, is where most of the string's energy has been stored, and so it goes on and on and on. Let's see if we can see that again. So just watching the upper display. The sharp corners are gone, and you can see the sound has changed. Oops, I hit a higher string there. distortion or what? Remember, I'm not a guitarist. Yeah. I'm going to demonstrate that quite clearly. So where are we? We're at full gain. Guitar's up full. It's just interesting looking at the wave shapes. So again, looking at the upper display, on the initial pluck of the string, there's a lot of stuff there, and it quickly goes away, and you can hear this. Some of that's going to be because of the amplifier, for sure. Let's turn down the amp here. Okay, so I think I have it down in the range here. So it's still turning on the green light. So we're getting some level of distortion there. How about the power chord? No, sounds nice and smooth. So the green light is on, so I think this thing is saying the 15% distortion is in. So we hit a single note here again. So there's the 150, 300. You can almost draw a straight line down the peaks of the harmonics. Almost. Look at that, the second harmonic is bigger than the primary. That's because of where I'm plucking the string. Let me pluck it right in the middle here. See, yeah, no, that makes all the difference in the world, doesn't it? Same thing with guitar pickups. You might wonder why guitars have multiple pickups. One of the pickups is basically a third of the string up, or a quarter up, and then the other pickup is very close to the bridge. So the pickup that's close to the bridge picks up the harmonics much, much better. Hey, let's try that. So I'm on the front pickup, the one that's closest to the center of the string. But if I go to the other pickup, can you hear the difference there? Let me plug it again. The interesting thing in doing this kind of stuff is you start to find out that your ears hear differences in sound that are actually super duper subtle, like really subtle, like tiny changes in frequency. You pick it up right away. That's what makes being a human being so wonderful. Well, I'm sure lots of other animals hear pretty much exactly what we hear too. Okay, now we'll add in the tubessence. Well, we'll get the red light distortion going here. Okay, interestingly enough, if I put a little distortion in. Yeah. Oh, I must be blowing the doors off this video. Okay, let's take a few readings on the vacuum tube here and see how they're actually powering it. So it's a 12AX7. There's the diagram for it right there. Let's see, a plate is on pin 1, plate on pin 6, pin 1, pin 6, and that's about all that we need to check. What voltage are they driving this tube with? Let's start with that. Okay, so pin 1, pin 6, so we're looking at this voltmeter here. It's on the 150 scale, so 75 volts about straight up, something like that. This is pin 1. Okay, so on pin 1 we're getting about 40, almost 50 volts on there. Okay, and we go to pin 6. Very same thing there. About all. I hear my cat meowing for me outside. So, do we have any curves here? 12AX7. No, but we have some plate maximum plate voltage 300. Where's the typical stuff? Typical stuff. Grid voltage. Heater cathode voltage doesn't give the typical operating level for the plate voltage. So, but you can imagine if it's a 300 max, it's probably 200 somewhere around there. Typically, these things are operated at. For characteristic curves, we refer to 6AV6. Okay, 6AV6. Let's take a peek and see some curves here, because this will help us. 6AVQRST. 6AV6. Here it is. Here, twin diode, medium mu triode. Well, it's quite a different tube. It's nothing like the 12AX7. Did I read that right? Before I. Yes, I'm able to get confused in just one page flip. 12AX7, 6AV6. 6AV6, okay. Let's see what we got here. Here's some curves. Maximum ratings, 300. Characteristics, typical operation, 100 and 250. It's just giving different factors you would have to take into account here. Let's take a look at these curves. What are these curves? So here we've got what is this? Average diode characteristics, halfway rectification. No, that's not what I meant. Here we are. These are what I'm after. Here, yeah. So here, plate voltage at the bottom, and plate current flow, and then the different lines for different grid voltages. So we're way down below 100 here. We're way down here at below the 50. Below 50. I didn't even bother drawing the line. So grid volt of nothing. You get 1 milliamp in the plate circuit. And if you have any, see, here's the problem here. If you had any grid bias at all, the tube is just driven right into nothingness. So we need to look at the voltage variation on the grid of the tube and see what they're doing with it, because if it's anything more than just a fraction of a volt, it's really in this curved area, and they want it operating in the curved area because they're trying to achieve distortion with it. You can do this with any tube. You don't need to use a 12AX7 to achieve this. In fact, operating a tube so far out of its design realm really puts it into a big question mark zone, and there's really no reason to think that a 12AX7, which I know audio people love, is in any way a special tube in here in itself. So we want to look at what they're putting on the grid. I can't really put a voltmeter on it. Let's try. Let's put the voltmeter on it. Grid. Wait a minute. 12AX7 grids are 2 and 7. 2 and 7. Now, this is not a very effective measurement. You might hear it. Well, you won't hear anything out of this now. Nothing going in or out of it. 1.5 volt full scale. Okay, now watch the meter carefully when I touch it. You see it kind of jumped up, so there's a charge there. Okay, let's try the other ones. The other one was 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Seven. I think the meter is bleeding away the charge. I'm not sure what's going on there. Should we put the scope on that guy? I have to set this guy up with inputs and everything to do that. Let's do it. Okay, so what I've got going here is I'm feeding an audio signal now from the audio signal generator here, a low level kind of microphone type signal, into the input on the amplifier. The output is going into my microphone mixer, and that's what you're hearing right now. You're hearing the tone from here on it. So we can do a couple things here. I've got the level coming in set very low. I was able to compare it to the guitar level that I was goofing around with, and I know this is a low level coming in because it's not switching on the green light until you get pretty high on the volume setting here. There it is. Now listen very carefully, and I think you'll see as the green light comes on, you'll hear something happen to the quality of the sound here. At the same time, I'm making sure I'm not going over on the audio limits of my computer in that. So here we go. Watch the green light and listen. So I'd say what I'm hearing when the green light comes on is a little extra hiss, a little extra noise. So I'm going to turn the level down here. I'm going to turn it up on the supply here. I'll try the same thing again. Okay, so I'm having trouble with the level on the video recording going over its limit. So I'm going to cut it back here a little bit. This is here. I'll try it now. Hard to say what we're hearing, isn't it? Because, and you know, if this is producing pleasant sounding harmonics, then we are going to have a hard time recognizing it because it just sounds like music, just sounds more pleasant. But let's look at it on the frequency analyzer here. We'll see what we see then. Okay, so you can see the tone we're sending out. It's 500 hertz, in fact. Yeah, that's what's dialed up on my signal generator. So now you cannot see me working the volume here. That's obviously I've turned it down. So I'm going to turn it up till the green light just comes on. Okay, right in there. And I'm just wiggling the volume up and down. I'm also looking at the display above, the upper display. Nice looking sine wave there. So what I'm going to do, I'm going to turn the microphone mixer level right up. This is the Tubessence mixer right up, and then I'm going to feed in a increasing signal level. Doing this here in my shop is I cannot see the level, the VU meters for the recording for the video. So I have to pop over and check that just briefly here. Actually, you watched that, didn't you? That's up on your screen, so you can actually see all the schmozzle there. So now you see the VU meters that I use when I'm recording. Those the green line bopping up and down there. Well, yeah, let's watch the green line. I'm just going to leave it like this. I'm going to advance the level, and can you still see the green light in there? Okay, here we go. So there's the green light already. Get up pretty high input, and then you're obviously hitting the top of something because the VU meter stops advancing. It just stops, and the distortion comes in. Lots and lots of distortion. So of course, I mean, if you're going to run an amplifier with distortion in it, it's going to be affected by the signal level coming in the first place, I would think. Now let's go back to this. So I'm going to repeat that now. I know I'm not going too far on the video level. So we'll repeat that and just watch what happens here. Okay, now you may not have been looking at both screens. So if you're looking at the bottom screen, you'll see and hear when the higher order harmonics start showing up. If you look at the upper screen, you'll see what's doing it. The bottom of the sine wave is being chopped. You see the very, very sharp point first shows up on the sine wave as I advance the volume, and you'll hear that in the headphones. Right there. And you can see on the lower display what is appearing. Doesn't sound pleasant to me at all. Is this what this tube amp is really aiming to do? So I'm going to turn down the amp input level, or the amp, I'm sorry, let me get this right, the gain on the Tubessence. Okay, I'm going to turn up the input level quite a bit. So we're really driving it now, input wise. I'm going to turn up the gain. I'm watching the screen here. So the sine wave above looks pretty messy. Interesting now. So the sine wave is distorted. Is it distorted by the Tubessence amp on purpose? Is this what they're really aiming for? When I get the level up high enough, those higher order harmonics show up and you start getting that sort of piercing, grating sound. But up until then, well, let's try it again here. I'm going to go up. I'm turning up the control on the Tubessence. Now I'm watching on the Tubessence device for the red overload light to come on. And it never does. So the distortion in the upper wave, it's possible it's coming right out of my signal generator that way, but I don't think so. And could that distortion be introduced by the tube? I don't know, I suppose. This flat bottom thing, so that's overdriving something beyond its linear range. Judging by the sharpness of it, I think it's a transistor somewhere in the circuit. Who knows? There's lots of them in there. There's integrated circuits, all kinds of stuff. It's going to have solid state devices with limits. Is this because of the tube? So I'm going to take a wild guess. We have basically two harmonics on the screen right now. We have the original at 500. Primary frequency, and then a harmonic at 1,000. Not much else. And you just have the bend at the top of the sine wave. So I go any further here, we start getting the bottom to come into the picture. So the bottom thing could be bad biasing of that 12AX7 or anything along the line, anything along the way. Or it's intentional, I don't know. How else can we test this guy? Well, let's see what he does with a lower frequency. Okay, so there's 200 hertz. Green light off. Green light just coming on. Same deal there. I advance the volume past a certain point and touching the volume control, and it's as if they're not there and then they are there. How can we find out if that first harmonic there at 400 hertz is the intended harmonic? You know, pull the tube out, it'll stop operating completely. That overload light to come on, so I'm gonna advance the input level. It's already up pretty high. Wow, it's really high input level from my experience with it. Still can't get that overload light to come on. Why not? This extra input level, I can see the third harmonic there at 600. I guess you would call that an even harmonic. Really, it sounds okay until you get it really high. That's a good way to train your hearing there. Well, let's go way high with the frequency. So I think that's 2,000 hertz there. 2,000. Not quite 2,000. You don't have to guess. I can look right on the computer here. Okay, we're not going to get to 2,000. That's the top of the scale at the moment. But I think it's pretty easy to see. 2, 4, 6. These are even harmonics. Okay, well, green light's off. Green light just coming on. Oh my gosh, look what's happened to the sine wave. It's flat topped. Green light just coming on. Once again, the distortive sound, the annoying sound, shows up when the bottom of the sine wave is being messed up. Maybe we can say this, that the upper distortion is on purpose. This is the 12AX7 doing its thing, generating some even harmonics. Now I'm just checking, yeah, all even harmonics. But if you push this thing too hard, you start getting undesirable harmonics. If something else is reaching its limit in the circuit. How they've got this thing designed to turn these the green light on, the red light on, I don't know. But so what about all that? So what about all that? What about all that? Well, let's see. I think it. 1 second here. So I think, this has given me better control over this. I know what it's doing now. I know what to look for. I know what to listen for as I fiddle around with this. I probably am going to fiddle around with this with my guitar. And I just need to have some understanding of what the heck's going on in here, along with how it sounds. Should we look at the signal on the grid of that tube? And why wouldn't we? Okay, let's do that. Static discharge. It's about 0 degrees out right now. It's going down today to -7 all day long. So we're going to want to look at the grids over here. We'll look at everything actually. We can start with a blade really. Hey, where did that hum come from? Some kind of ground loopy thing going on. Hey, where are you? Okay, first we're going to look at the plate. It's on AC, so the DC voltage on the plate shouldn't throw it too far. What was that? That was pin, what was it? That was pin 1 and 6. You know what, I think I can clip it right on here. Well, not much there. Okay, so give us a little signal here. What? Well, that's just a little bit of a surprise what's happening there. There appears to be a DC voltage going up and down on this. So let's take a look at it. Okay, zero it. So that's 0 volts, dead center. Yeah, yeah. Okay, for those of you who would rather see a line, let me put the line on. Okay, there's a line. How much voltage? 20 volts, 1, 2, 20 volts per division. That's 45 volts, that's plate voltage. It's not bopping up and down. Wah, 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 wah. What the heck did I see before? Okay, so maybe I hooked up to the plate. Maybe I'm a bozo. Yeah, I have hooked up to the plate. That is what I chose. I chose to hook up to the plate. Hello everybody. So, why can't we see a signal on the plate? See, I don't know how they've wired this guy up. I have to start looking at the schematic. I have looked at the schematic, but I certainly haven't looked close enough to figure out what they're doing here. Let's look at the grid. So the grids were 2 and 7. I think I can clip on again. Okay, now the oscilloscope can just ruin the grid, but let's get on it anyway. Get on there. Stay put. Okay, there's something showing up. It's not enough signal there to trigger. There. Wow. Nothing too good about that. Let me change the gain now on the amp, if you can see my hand here. Well, that thing's flat top the whole time. Flat topped. The bottom's distorted too. Get a bit of a sharp edge right in here. It's giving it a high harmonic content. Again, top is kind of smooth, the bottom is sharp. Okay, that's with a very high input level. Let me turn down the input level here. Because it could just be simply overloading the front end, but I believe that's what this light is all about, this red light, which I have not turned on yet. Here we go. So it looks like a nice smooth wave, but in fact this top is kind of flattened out. It's not flattened out sharply though. So it would be giving you the warm harmonic. The warm harmonic appears to be there on the grid. Go back to the plate here. Let me flip this over to AC only. So we're unable to see the signal because of something peculiar about how they've wired up this tube. Maybe there's no plate resistor. No plate resistor, then you haven't got that voltage divider thing happening with the tube and the plate resistor. So there's just plate voltage. We can't hear the signal coming out of it. But somehow this is heard somewhere inside here. It should be across the plate resistor, wherever the heck that is. So there's another grid. What do we look at the other? Well, the other grid should be for the other signal. The other grid would be 987. This one here. But I don't think there should be anything on it. Yeah, there's not going to be anything on that. It's on here. Yeah. So the assumption is the other channels working the very same, and I'm not going to bother looking into that. There are some adjustments in here, various resistors, probably for setting biases within the device. Those could all, there's quite a few of them. So 1, 2, 3, 4, 5, 6. 6 anyway. Again, I have to have the manual. I have to know what I'm doing here to fool around with those, and I don't. So, well, my guess is this is working exactly the way it was intended to work. My guess is the distortion we see in the upper part of the sine wave is what this thing is trying to make happen. The result of that is even harmonics, which are supposedly pleasant to hear. If you drive it too hard, even before the overload light comes on, you start introducing another kind of distortion. Maybe that's coming from the tube. Maybe it's coming from something else. I don't really know for sure. And the result of that, you know, I'm going to tell another piece of the story just came to my head. But the result of that additional distortion at the bottom of the sine wave is terrible sound. So what that tells me is, you turn this up till the green light's just coming on. You listen hard to what you're hearing. If the red light's coming on, you're way too far. But I'm telling you, it gives you some really nice distortion on the guitar. So that's what I think I figured out from this guy. I'm not sure there's anything else we can really do with it at this point. Yeah, I think so. So I think it's pretty much doing what it's supposed to do, and it's operator sensitive. And by doing this little experiment here, I think I've nailed what the operator, me, has to be aware of. Again, which is the two lights and the fact that some other distortion comes in long before this red light comes on. Great. I think that's it for Tubessence. I got to decide what to do with it. I think I will incorporate it into my guitar playing stuff. You know, like I need all the help I can get. So, and a little extra distortion might be just what I need. So, well, thanks a lot for watching. I hope you found that interesting. And I'll get back to doing some radio work soon.